Hi everyone, I'm Whitroy. In this lesson, we'll explore the main calculation topics that may appear in EWRB Electrician Theory exam. In this lesson, we're going to explore the most common calculation questions, from current, power and resistance to motors, transformers and fuses. Each type shows a simple way to understand, calculate and apply in real jobs or exams. Let's begin with the most common, finding current in a circuit. We start with the most basic formula, current equals power divided by voltage. It helps us find how much current a heater or any load draws from the supply. For example, a 2 kilowatt heater on 230 volts takes about 8.7 amperes. This one's about resistance. When you know a heater's power and voltage, you can find its resistance. Square the voltage, divide by power, and you'll know how much resistance is inside the heating element. Here's the reverse. When you know resistance and voltage, you can find power. This is used for circuit load checks or to verify equipment ratings. Three-phase power is everywhere in our trade. Multiply voltage, current and power factor by square root of 3 to get total power. If you know power, rearrange to find current, simple and essential for motor circuits. Transformers reduce or step up voltage. Once you know the kVA rating, use the three-phase formula to find line current. Always check which side, primary or secondary, you are working on. Motors convert electricity to motion. We find synchronous speed from frequency and poles. If the actual speed is slower, the difference is slip, usually a few percent for induction motors. Power factor tells how effectively current is used. Efficiency compares output to input power. In motors, both matter. Good efficiency means less loss and lower running cost. When a fault occurs, current can rise sharply. We divide voltage by loop impedance to find this fault current. It's critical for choosing correct breakers and fuses. Touch voltage tells us how dangerous a fault can be. A good earth path keeps this voltage low and safe. Always check resistance. A small resistance means better protection. Every cable has resistance, so voltage drops along the run. Use tables to find millivolt per amp per meter. If drop is too high, use a larger cable to stay within 5% limits. Each fuse takes more than its rated current before blowing. Multiply the rating by its fusing factor to find actual operation current. It helps check protection coordination. Once current is known, use ASNZS 3008 tables to select cable size. Consider factors like temperature, grouping, or installation type. Not all energy turns into useful work. We calculate loss and efficiency to see how much is wasted as heat. Higher efficiency means better system design. Transformer regulation shows voltage drop under load. Lower percentage means better performance. This checks how much energy goes in versus what comes out as work. It's a key step for verifying nameplate data. Protection devices must handle the highest possible fault. Always match device rupturing capacity to calculated fault current. We've covered every major formula, from Ohm's law to transformers and motors. Remember, always show the formula, substitute numbers clearly, and include units. Practice often, and you'll master every question in the exam.